This question says, which of the following 5 acceleration versus time graphs is correct for an object moving in a straight line at a constant velocity of 20 meters per second? So constant velocity, they give us that it's a positive value. We're assuming that they've labeled a coordinate system, and in our coordinate system we're moving at 20 meters per second. And we're looking at acceleration versus time graphs. So we got to notice our coordinates. A very key thing to do in this problem is to notice if we have acceleration versus time graph. We really need to know what our coordinates are. We're looking at velocity. So we know that the acceleration is equal to the change of velocity over change of time. Or thinking of this in another way is using one of the other kinematic equations. The velocity is equal to the initial velocity plus the acceleration times time. And this is actually going to be our second equation, is going to tell us how to solve this problem. We are looking at a constant velocity, which means any velocity always has to be our initial velocity. So if our final velocity, whatever final is, final can be any time, really any time we want it to set it at, as long as we have a corresponding time, in this case, has to be equal to our initial. This says that we have a constant velocity. And actually, we can go one step further and call this 20 meters per second. So we need to find the case where, because of these things, our acceleration is equal to 0. If our acceleration is equal to 0, then our velocity cannot change. The acceleration graphs do not tell us what our initial velocity was, but it'll tell us how our velocity will change. And our velocity is not changing, so we need no acceleration. So I'm looking at all these graphs, and I find that E looks like the correct one because it's the only one that has acceleration for all the times is at 0. And we need acceleration for all the times to be 0. This case up here, case A, is a very likely one to choose. So don't feel bad if you chose that one. But this is a likely one to choose. This says that you have a constant acceleration. Constant acceleration would provide us with the ability to use this equation. This is for constant acceleration only. And it would say that the problem would be our velocity, our initial velocity, as we would increase our time, 1 second later, this initial velocity would add some amount to it. So the final velocity, or the velocity at 1 second, would be different than what it was when it started. So it would no longer be at the constant 20 meters per second. But this is a common graph to see. It just doesn't fit this graph. All these other graphs in here are actually more complicated graphs than you normally see in introductory physics. These say that the acceleration is changing. Not saying that we won't see changing accelerations, but it's not a common thing. And actually, this equation right here only works for constant acceleration. So these 3 graphs, we can't use this equation or the other kinematic x equals x naught plus v naught t plus 1/2 at squared. We can't use that equation to even solve problems because the equation is not complete.